Assalamu alaikum student. I hope that you all are fine. Last time we have studied about reactivity of alkane. But in this video we will discuss about first year chemistry, and I am going to start the third chapter of first year, that's related to states of matter. We all know that there are four states of matter: first gases, second liquid, third solids, and fourth is plasma. We can define gases as the state of matter having no fixed shape and no fixed volume, and the molecules are very away from each other. There are very weaker forces of attraction. We can say there are no forces of attraction among the molecules. And in case of liquid, we can define the liquid as the state of matter having fixed volume but no fixed shape. And in this case, molecules are closer to each other and they have a stronger force of attraction than in case of gases. On the other hand, the third case is about solids. We can define solid as the state of matter having fixed shape and fixed volume. And in this state of matter, the force of attraction are very, very greater. So they can easily maintain their shape. The fourth state is plasma. The plasma is rare state on Earth, and it can only be found on it can only be found on stars and the sun. We can artificially prepare plasma on the Earth. If we have a discharge tube filled with gas, we can create plasma by applying electrical current or heating that gas. Actually, plasma contains positively charged ions, negative electrons, and neutral molecules or atoms. In this video lecture, we will discuss about gases and the laws that are followed by the gases. The first law is Charle's law. Charle's law. According to Charle's law, I am going to define the Charle's law. The volume of gas is directly proportional to temperature. Volume of gas is directly proportional to temperature. It means when we increases the temperature, the volume also increases, and when we decreases the temperature, volume also decreases. While what are the conditions? At constant pressure and number of mole. Small n represents number of mole. What is the mathematical form of Charle's law? We can write it as the volume of any gas is directly proportional to temperature. As number of mole and pressure, these two things are constant. These are constant quantities. Solving this mathematical form, we gain V is equal to K into T. K is a constant. Now we can rearrange this mathematical form that K is equal to V over T1. V over T. If we have two systems, first system has volume V1 and second system has volume V2. Similarly, the temperature of first system is T1 and second system has T2. I am going to write the conditions. Here is the volume V1 and temperature is T1, and here is the volume V2 and temperature is T2. For example, here is a piston, and it is movable piston. It is movable piston. Its temperature is T1 and volume is V1. Now I am going to increase the temperature by heating this mixture. This piston moves toward upside, and the second volume becomes this one. Here is the volume V2 and temperature is T2. Now we can write the K expression as K is equal to V1 over T1, and it is also equal to V2 over T2. How they are equal? Because when we increases one parameter, the other parameter also increases. So their ratios are in constant quantities. For example, I am going to write, we have the ratio between 3 and 6. It has answer 2. And we have ratio between 10 and 5. It will have answer 2. We are looking at when I am going to increase the values of both factors, then we gain the same answer because it's in ratio. It's in ratio form. So it will be constant. Next is graphical representation of Charle's law. Graphical representations of Charle's law. Taking the temperature on y-axis and the volume on x-axis. Here is the graph between volume and temperature. Here is the temperature and here is volume. For example, we have the system here. And when we increases the volume, here is the volume V1 and here is the temperature T1. And when we increases the temperature, the volume also increases and we gain the straight line that's originating from the central point, origin. And it is a straight line. You can write its graphical representation as when we increases the temperature, the volume also increases. And when we decreases the temperature, volume also decreases. I hope that you have understood about Charle's law. Note one thing more, that Charle's law is only acceptable at absolute temperature. When we have to solve any numerical problem, we have to take the values of temperature in Kelvin scale. We cannot take the values in Celsius scale. Because when we take the values in Celsius scale, we take wrong answer. So keep in mind that the Charle's law is only acceptable at Kelvin scale. It is acceptable at Kelvin scale. So when you are going to solve any numerical problem, first of all convert the values of temperature that's maybe in Celsius, convert it into Kelvin scale. Now if you have any question regarding Charle's law, you can ask in comment section. Thank you, and please don't forget to subscribe my channel and share my videos to other students. Thank you and Allah Hafiz.